So. Hello and welcome back to Precalculus 1, section 1.3, the revenge of functions, right? So this is a third lecture actually in a textbook. So 1.1, 1.2, 1.3, they all deal with basics of function, basic notions of function. And this one in particular deals with increase, decrease, min, max values, and then domain as a very important part, which we already touched upon previous time. Now we're going to do much more of that. So first off, we said that the function is a rule which assigns to each x a unique y in the range. We said that the notation for function is y equals f of x. And we said that the example for something like that could be, I don't know, x minus 3. But then we also seen other examples as f of x equals square root of x. We've seen f of x equals 1 over x. And you know what? It's kind of difficult when you look at all of this, f of x, f of x, f of x, because f, yes, function, right? The letter f can be replaced by any other letter out there. You can come up with whatever letter you want, because eventually I will talk about population. And population, hopefully, right, you will use the letter P for population, and it will be population in time. So we will use P of t as, right, so when you're thinking about notation in functions, you are not bound to use only f. You can use any other letter as long as there is a function, which means the values are changing. You can use whatever notation you want, but we try to use appropriate letters. So P for population and then T. So instead of writing f of x, I have P of t for population in time. Now that's coming on later. I just wanted to make sure that you don't freak out if I write age of x equals and you go, whoa, what's age of x, right? It's still a function. It's just I'm using a different letter to distinguish that it's a different function than the previous example or the previous problem and so on. So we have this. Now, let's take a look at an arbitrary graph here that does this, right? We see that somewhere over here, there is a max value at this number A, and somewhere over here there is a min value at B. So, and I don't even know what this function is. I'm just going to call it f of x. It will have some kind of equation. And there are methods in mathematics to figure out what that equation is. You guys will have a problem on the project to fit the function to the data. Actually, before you hit the problem on the project, each one of your labs will have applied problem where you are going to fit data into a function, which essentially is what you will be making money with if you are using math and science and engineering to make money. All right, so let's analyze this graph. First of all, x-axis and y-axis are not graph. When you don't have this line, right? If you don't have this line, then this particular thing is just called coordinate system, right? So this is just called a coordinate system. If you put the line, then it's graph. So this line is the graph. That's the most important part on the whole thing. X and Y are guidelines, and then you have the divisions and so on. But the graph is the most important thing. Now, what do I have? I have a maximum at a f of a. Remember that to compute the value at a, I plug that into f of x. Well, when I replace x with a, I get f of a. I don't have any numbers to plug in, so right. So I have a maximum there. I have a minimum at b f of b. We also understand that this function will go forever and ever and ever and ever and ever in those directions. So if you want to, you can put these little arrows at the ends. We are going to learn about the end behavior in chapter 2. So those will be back in a picture, those arrows. So now you are looking at the graph. You are familiar with the idea of a minimum and a maximum, like largest point, lowest point. And then another part that we are going to talk about is interval of increase and interval of decrease. I hope you see that on this part, function goes up. And also here, function goes up as you move towards the right. We call those increase, right? Increasing parts. So f of x is increasing on, and note what I'm writing. I'm not putting any points from the graph. This is a lot of mistakes from this on exams. Function is increasing or decreasing over the interval. And you read x values for that. So the function, this particular function, is going to be increasing from negative infinity to a union b to positive infinity. So these are intervals. They're not points. Point is x comma y. This is x comma x. It's from x to x. Like when you give interval of time. I'll see you sometimes between 2 and 3 p.m. Right? You don't know what time you're going to arrive because you have to plow through traffic. Right? So you will be at your friend's place anytime between 2 p.m. and 3 p.m. That's interval of time. So time 1 to time 2. Here is your x1, negative infinity, x2, a, x3, b, and then positive infinity, x4. So from x to x. So function is increasing over this interval. Union, because I have to join two different intervals together for the same concept. And I will put the color there. And then I'm going to have this green thingy here. So f of x is decreasing on a to b. And that's this color. Again, interval. A is x value, as you can see, and b is also x value. So as a quick exercise for you guys, I will ask you to solve two problems. So give increase, decrease regions. The first one is y equals x squared, which is the parabola you all know and love. And the second one is y equals 1 over x, another graph that you will have to memorize in this course, and the graph that will never go away actually through your calc education later. All right. So you have the example of how you're supposed to write it if you have multiple regions. Let's see what you get. Yes.
For the interval next to A, are we supposed to do it in brackets or
Parentheses, because it is. So remember, the difference between parentheses and the bracket is that one point at the end, right?
Yeah.
You cannot claim increase or decrease at a single point.
Okay.
Does it make sense, right?
Yeah.
You have to have at least 2 points to have a reference, and then whether it went up or down.
Okay.
So that's why we always use the open intervals, because it doesn't matter that one point doesn't matter. It will matter in calculus for continuity, and other things will have to be done. Clearly matters for the domain, which is the next topic. I mean, within this lecture, right after this. So it will matter, but for these ones, we'll use open. So you should have this statement for both, and then whatever this works, right? To talk to those people that exist around you.
Why is it going back? I get it. I'm trying to go this way that way, but now it's going in one direction, but you're gonna look this. Or people just decide it's not functioning, that's why you're not knowing what the whole it is. You get what I'm saying? No matter what, this to last, you can't just go from here to here and act like it's going up. You can't do that. It has to go in one direction. So I'm guessing it's going like here, and then it's increasing here. You can't just be like 0 to 3, and then decrease and all you say it's like 0, like switch. So why are you saying what goes outside? Okay, yes, but he had it there on Y too. So I'm guessing that way he had it explained in gray. So basically,
That's what I keep telling them. Atomic level. That's what I keep telling. That's when my equations come in. Like, do you stop? It's greater than zero.
but why though? Because the only reason why he put A and B is because he was talking about that there's two increases there. He's going from every infinity to when we went from B to infinity. It's not enough, they're both increasing. Okay, you're talking about the points, yes, but they're both increasing. Where there's no, where we didn't define that as given variables in the time in the point of view.
Okay, let's take a look at the problem together. So I will say that we have f of x is decreasing on negative infinity to 0, which would be, so that's the decreasing region, part of the domain, interval, right? And then we have the increasing part, which is the green part here. So f of x is increasing 0 to infinity. It doesn't matter which one you write first, which one you write second. It's just important that you have the intervals correct. So from x value to x value, from x value to x value. Yes?
Reading card, when I was looking at first one to see, I saw like where it was decreasing, but where it was, increasing, it's easy, but decreasing part was.
Well, you either, so we all read from left to right except Japan, or no, actually no, Arabic is also backwards. So, hey, how about this? In United States, we read left to right. How about that? So, as you are looking from left to right, if you picture yourself, this is not my best representation of you on the graph. I can probably do better, but that's it for now. Deal with that. Would you agree that you are going down the line? So that's a decrease, right? On the other side would be a hike.
Yeah, when you say it like that, yeah.
Beautiful. That's exactly how it is. It's while decreasing. It's going downwards as you move to the right. All right. So on the other side, what do we have? What do we have on the other side? They're both decreasing. Very good. So on the other side, I have that f of x is decreasing on negative infinity to 0, union 0 to infinity. Note that I actually have to make this break. I have to make the break at 0 because at 0 the function does not exist. 0 is not in the domain because I can't plug 0 in the equation and compute. 1 divided by 0 does not exist. Yes? No, you have to go from negative infinity to 0 because negative infinity and positive infinity are different concepts on the one-dimensional line. In a 2D, they fall into the same point, but it's going to be way beyond calculus. So we start reading on the left, right? So negative infinity, stop at 0, pick up at 0, positive infinity. Read left to right. Yes. Yes, that's where they live. So I would say the negative infinity lives here. Then you have a negative 1, then you have a 0, then you have a 1, then you have positive infinity on this end. Those are the values. When I have two intervals that need to be joined together with the same concept. In this case, both of these parts of function were decreasing. If you look the left graph, one is increasing, one is decreasing, so we get two different lines because one is for increase, one is for decrease. On the right side, both are decreasing, so function is decreasing at these two parts united. You can unite 3 parts, 5 parts, 10 parts, depends on, or infinitely many parts. Guys, you are going to have the same thing in your Precalc 2 next semester, except you are going to do that on a tangent function. The tangent function will be infinite repeat. So you are not going to, so here's the tangent function, the vertical asymptote, tangent function, vertical asymptote, tangent function, vertical asymptote. So it's going to look like this, and you see that you have infinitely many of these. So you would have infinitely many of these intervals that are all united into increase, 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 right? So tangent is increasing over the entire domain. Every one of these vertical asymptotes, which what is also what we study here. Concepts that you are learning in chapter 1 never go away, and they are recycled for every type of a function you will ever learn, including the hyperbolic functions in Calc 1 and so on. So, Calc 2. So, do yourself a favor and do not forget or miss a single concept from chapter 1. When I start talking about polynomial functions in chapter 2, I will go back to chapter 1 and pick the concepts, because chapter 1 is general story about functions and properties of functions. So functions in chapter 2 will have the domain and the range and increase, decrease, mean, max, all of that. Then you go to chapter 3, logarithmic exponential functions. They will have the domain, the range, the right, and all of that. So learn everything in chapter 1 extremely well. The rest of the Precalc 1 and Precalc 2 will be, yeah. If you don't learn chapter 1, the rest is going to be hell on earth. Right? The oven, and you can make cookies in the oven, actually. All right. Domain. We talk about domain. So that was increase, decrease, min, max. You use your eyes and you look at it, right? But now domain. For domain, we need to know a few things. So we already defined the domain as the set of all x values which we can plug in into f of x. we've seen before that f of x equals, let's say, 2x plus 1 will have the domain negative infinity to infinity, which means any number is okay. Right? When you pick from negative infinity to positive infinity, you are picking all numbers. That includes pi over 2. That includes 1/2. That includes square root of 0.000375330. Okay? All of those numbers are included when you say negative infinity to positive infinity. We've seen f of x equals 1 over x. We said negative infinity to 0, 0 to infinity. So anything but 0. And we also seen f of x equals square root of x, where we said positive numbers and 0. So you can just write, 0 in a bracket to infinity. So I'll say non-negative numbers. Yes?
On the first one where it says any number is what?
Is okay. Oh, it does look like ole. All right, fine. Yeah. Now, to look for the domain of functions, we are primarily considering numbers which we are concerned with numbers which work for us to calculate. You can memorize these if you want, but as soon as I modify them slightly, it's going to be an issue. What are you going to do if I say f of x is equal to square root of x plus 5? Is the domain, x minus, let's go x minus 5. So is the domain still okay to be 0 to infinity? And the answer is hell no. If you try to plug in 0, what happens? 0 minus 5 is negative 5, and we are not supposed to take a square root of a negative number, right? So for default state, that's the answer. As soon as you modify it a little bit, hell breaks loose. You cannot learn this class example by example, and don't even try to just show up for the class and try to pick up things because, as I say, they make sense. This class will not work like that whatsoever. You have to sit there and say, okay, what was the concept? I can only take the square root of positive numbers and 0. Look. That's how you solve it. Because that inequality says that this thing must be positive number or 0. This is what says positive number or 0, right? Equal is 0 or larger than. So when you are looking to find the domain for square roots, you are essentially taking the argument of the square root. That's called the argument. This whatever is under square root is called the argument. So you're taking the argument of the square root and you set it larger or equal to 0. Now, you say, oh, I remember that. It's much more valuable if you understand why I did that. Again, this is the process of thinking. I need the domain for this. I know that I am only allowed to take numbers of positive numbers and 0. I need to make sure that this is positive number or 0. This is how you mathematically write that as a statement. Argument is positive or equal to 0. And you just solve that. Obviously, just move 5 to the other side, and you get x larger or equal than positive 5. So what is the domain? Domain is 5 to positive infinity. And then you check. You check. Pick values. Make sure it works. Care, right? So, you say, all right, let me pick 5. 5 minus 5 is 0, square root of 0 is 0. I was able to plug it in, so 5 is in the domain. I don't care what I get on the end. I only care if the calculation is possible. I don't have to take the calculator and figure out what is the number. I just don't want to see any negatives under the root. So plug in 5, we get 5 minus 5 is 0. I know I can take square root of 0. Well, you all know that square root of 0 is 0, but, right? Then you can say, okay, let me try 10. 10 minus 5 is 5. Square root of positive 5, yeah, that's possible. Some of you know that square root of 5 is approximated by 2.23. Some of you will have to take their cell phone and get it. But the idea is that it's possible. I don't care what it is. It's just that it's possible. Domain is the set of values that are allowed to be plugged in. So we are claiming that any number starting from 5 on to infinity is okay. We tried 5, we tried 10, worked for both of them. Let's see what happens with with the 4. Like 4 is not in the domain, and that should break this. Plug in 4. 4 minus 5 is negative 1. Root of negative 1 is not real. So we see that it doesn't work for 4. But that's okay. 4 is not in our domain anyway, right? So you can test it by picking purposely the point that you think might not work, and then you also see that it doesn't work. So it's awesome. It worked for 5, it worked for 10, it didn't work for 4. That's good enough, right? Looks okay. Move on with your life. How about g of x equals 3 over x plus 6? What now? What would be the domain? The set of all numbers that I am allowed to use? Or is it easier to find what I'm not allowed to use and then like a complement? So say g of x. Anyone? Yes?
Set it greater than or equal to 0? The fraction?
Well, not in this case because what are we not allowed to have? Yes.
Set it not equal to 0?
Okay, what does that mean now? Not equal to 0, like what? What are you setting not equal to 0?
Greater than 0? It can't be 0.
What can't be 0? The denominator. Okay, so what's the denominator? You had your hand up, yeah. Good. So x plus 6 is the denominator, and that is not allowed to be 0. So what x cannot be? Negative 6. You solve this equation the same as any other equation, except you have a not equal sign there. You subtract 6 to both sides, and you get that x is not allowed to be negative 6. So what is allowed? If negative 6 is not allowed, what's allowed? Everything else. How do you write everything else but negative 6? Yes? Well, that will take care of the part of it. For partial credit, right? Yeah. Good enough. Yes. So you have to understand that your entire number line is from negative infinity to positive infinity. We are kicking one number out, negative 6. So from negative infinity to negative 6, and then from negative 6 to infinity, union in between to make sure you get this. Okay, cool. We have 47 seconds. Enough for one example. Now, you can also combine these. What happens if the problem says h of x is equal to x over square root of 5 minus x? Again, 5. Let's change 5 into... I don't think I used 8 too much. Let's use 8. All right. So now we are looking at this. Your square root is back. What do you know about the square root? You set the argument greater or equal than 0, right? But you have to modify it in this case because it's in denominator. You're not allowed to have equal 0, right? Square root of 0 is 0, right? That's an issue. So if the square root, so this is where the thinking and analysis and thinking about problems kicks in. If you just memorize any time I see square root, I put greater equal, well, you're going to run into a problem like this when it's just greater because the square root was in denominator and you can't have equal 0 because it's in denominator. Do not learn this class problem by problem, example by example. You have to understand and figure out concepts. Domain is the set of numbers that you are allowed to plug in. When you have denominator, all of the numbers that make denominator 0 are not allowed into domain. So in this case, 0 would work for square root, but because square root is in the denominator, I have to kick out that equal part. So now I have negative x larger than negative 8, and then hit both sides by negative 1, x smaller than 8. So now we have negative infinity to positive infinity on top, and we have negative infinity to 8 not included on the bottom. What is the overall domain? Overall domain is the one that it's more restrictive, which in this case is the one in the denominator, from negative infinity to 8. Recall that you are allowed to plug in anything for x. But if you plug 10 for x, you are going to run into situation 10 divided by square root of negative 2. And that's not good. So it's the more restrictive domain that is going to be domain when you have multiple domains, right? This has its own domain, this has its own domain, and then whatever is the most restrictive one on the pile, that's the one that it's the domain for the entire problem. I have a little anecdote for that. So say you are at a train station with your grandma, right? The train is leaving, the doors are still open. If you run half a pace, you're gonna make the train like this. But the problem? I know. It's domain, it's the restriction, all right? So that's you, that's the grandma, and you can move at that pace. All right? See you all in 2 days. Take a look at homework online, and if you're doing on paper. I don't know what you did with class prep. Oh no, yeah, this is the ruined course. Yeah. All right. Anyway, so see you all on Wednesday. No, Thursday. Whatever. See you next class. I show up.